Good morning. We are on the last lesson of Chapter 8, and it's 8.8, surface area and volume of composite figures. So today's lesson is really nothing new. It's all of the formulas that we worked with so far for surface area and volume, but you do have to be very aware of your figures, very aware of kind of the spatial like just visualizing what part of the figure is overlapping, and you've got to be very organized with your work. So follow along carefully. There are no goddets. I took off the goddets on page 690 and 691 because I was not a fan of the figures that they used. So you do not have to do those. Just follow along with the notes. There are 4 examples. They do take a little while, so but as long as you keep your work organized and labeled, you'll be good. So find the volume of a composite figure. Remember, the composite figure is just 2 figures stuck together. So volume, we're talking about the space that it takes up. So we are going to look at the volume of, I'm going to start with the, I'm going to call it a rectangular prism, but it's also a cube because it's 8 by 8 by 8. We're going to add the volume of the rectangular prism to the volume of the square pyramid. And then we're going to write our formulas. So we start with the figures, just like we did with our 2-dimensional figures. So for a prism, rectangular prism, its volume equals area of base times height. Since the base is a square, it's length times width and times height. And then I'm going to plug in what I know. Length is 8, width is 8, right? 8, 8, height is 8. All right, and then I'm going to go over to the square pyramid. Since it is a pyramid, the volume, the formula is not the exact same. It's very close, but it's 1/3 area of base times height. And again, go ahead and refer to the formulas in your notebook if need be, if you don't have them memorized. Area of the base, since it's a square, it's length times width times height times 1/3. So 1/3 times length and width, 8 by 8, times the height of the pyramid. It is not the 6.4, that's the slant height. I think, early on in the first couple sections, I talked about them giving us extra information. Here, we do not need the slant height, that's 6.4. We do not need that. They just gave it to us to see if we understood the difference between the slant height and the actual height of the pyramid. So the actual height of the pyramid is 5 feet. All right, so 8 times 8 times 8, we get 512. Remember, keep that addition sign. And then, let's see, 1/3. Remember, do not make 1/3 0.33. Keep it as a fraction. So depending on your calculator, you can do parentheses 1 divided by 3, close parentheses, or use your ABC button. So 1/3 times 8 times 8 times 5, we get 106, 106.66. Normally, I would say do not round within your problem. However, because it's going to be repeating, go ahead and round to 106.7 in this case. And then 106.7 plus 512. We get 618.7. And since it's volume, it is feet cubed. Alrighty, so we're just adding the volume of both figures. And again, pause me if you need to get all the work down, to make sense of exactly what I did. I just don't want the video to be super long. Alrighty, example 2, we're finding volume again. The reason I was not a fan of the figures that were used for the Goddets is because they don't look like that in your homework. So if you look at your textbook for Goddets A and B, the figures look very different than what you would see in your homework. This figure is like what you would see, so I would prefer us work with those. Find the volume of the composite figure. So we need to figure out what two figures we're working with. We're working with two square or rectangular pyramids. So we're going to add rectangular pyramid to another rectangular pyramid. And since we're finding volume of both of them, we need to be comfortable with that formula. So it's a pyramid, so it's 1/3 area of base times height for both of them. 1/3 area of base times height. And since it's a rectangle, it's length times width for both. Okay, I'm going to start with the top. Be sure you label which one you're working with, top and then bottom. Alright, so the top, got 1/3. My length and my width of the top of the base is, let's see, 5 by 4. The height is this 7. Alright, I'm going to plug in for the bottom one now. 1/3. The length and the width will be the exact same. 5 by 4. The height is not 7 though, it is 8. So the bottom is a little bit longer. Alrighty. Let's see, 1/3 times 20 times 7, we get, oh nuts, we get that, let's see, 1/3, yep. We get 46.666 repeating, so we're going to round to 46.7. And we've got 53, and it is 0.333 repeating, so we are going to make it 53.3, so round to the nearest tenth. 53.3 plus 46.7, we get 100. And its volume, so it's 100 inches cubed. Alright, and again, normally I would say do not round within your problem. However, because it's repeating, we rounded to the nearest tenth. Alrighty, we are moving on to surface area. Surface area is where it gets just a little bit tricky, so stay with me here. Surface area of the composite figure. So, similar to volume, we're going to find the surface area of both figures and add them together. However, we also have to subtract a portion of the figure that is overlapping, because the surface area is like you wrapping a gift. So if you stack two gifts like this on top of each other, you're not gonna, well, you probably actually would wrap them individually. However, pretend you're tying them together and then you're wrapping the whole thing, which would be an awkward gift, but that's fine. So it would be, you're looking for all of the parts that are exposed, right? But look here at the bottom of this top figure. It is not exposed because it's attached to the top part of that bottom figure. So we're going to find the surface area of the top figure, find the surface area of the bottom figure, add them together, and then subtract the overlapping portion. However, the overlapping portion is not just on the bottom of this top figure. there's also a portion of it that needs to be taken away from the bottom figure. So it's like this area times 2, because the bottom of the top figure and the top of the bottom figure are touching, so we need to subtract that from both. Alrighty, so let's go ahead and start with our kind of layout. We are going to add the surface area of, let's say, top rectangular prism plus bottom rectangular prism minus 2 times whatever the overlap is. Alright, so surface area, it is 2 times length times width, and again, whatever order is totally fine. Plus 2 times length times width, plus 2 times length times height, plus 2 times height times width. Alright, minus 2 times, now the overlap, again, is this portion right here. So the overlap is 4 by 5, because this is 4, because it's the same as the top, and this is 5, because this is 5. So 2 times section 4 by 5, because it's the bottom of the top figure and the top portion of the bottom figure. Alright, now let's start plugging in what we know. So the top rectangular prism, we're dealing with 4 by 5 by 5. Alrighty, so 2 times 4 times 5 plus 2 times 4 by 5 by 5. 4 times 5 plus 2 times 5 times 5. And again, this part is nothing new. It's the same thing that we did, let's see, yesterday or the day before. The bottom rectangular prism, we're dealing with 9, 5, and 4. So 2 times 9 times 5 plus 2 times 5 times 4 plus 2 times 9 times 4. And again, whatever order that you are adding those in, it doesn't matter. Minus 2 times, and then I'm going to go ahead and simplify that to 20 for now. Okay, 4 times 5, we get 20, times 2 is 40. 4 times 5 is 20, times 2 is 40. 5 times 5 is 25, times 2 is 50. 45 times 2 is 90. 5 times 4 is 20, times 2 is 40. 9 times 4 is 36. 36 times 2, we get 72. Wait, 36. Yeah. Minus 2 times 40. 2 times 20 is 40. Alrighty. And then we're going to go ahead and add everything together. So I will, for the sake of keeping everything organized, I'm going to add each portion together individually first. Okay, so 202 plus 130 is 332 minus 40. We should get 292. And it is surface area, so it's yards squared. So I think the big part here is paying super close attention to whatever is overlapping and how many parts of that overlap do you need to account for. Usually if it's a figure on top of another figure, it's 2, because both parts of the figures that are overlapping need to be accounted for. There is a problem, let's see. Number 4 in your homework, be careful with that. There are 3 figures, so the number of overlaps is more than 2. And you'll see that in the answer key on the homework, but just pay close attention to number 4. Alrighty, example 4. Find the surface area of the composite figure. Alright, so we've got to find the surface area of the bottom, of the top, and then subtract the overlap. So let's do the bottom first. So we've got a rectangular prism. Then we've got a triangular prism. And then we've got, just because there are 2 figures, we've got 2 sets of overlap. Alright, so rectangular prism, surface area, we've got 2 times length times width, 2 times length times height, plus 2 times height times width. For the triangular prism, we've got, this is the one where it's not a perfect formula, right? We've got 2 triangles plus 3 sides. Okay, minus 2 times the overlap is going to be this portion. So it is, let's see, this part is 6 by 7. So 2 times 6 times 7. Alright, because that triangular prism is a little weird, let's go ahead and break it down a little bit. The 2 triangles, let's see, so 1/2 base times height. So 1/2, the base of the triangle is 7. The height of the triangle is 5. We've got 2 of those. Yesterday, Lucas made the point of, do we have to do the 2 times the 1/2? No, because it's just 1. But I'm going to write it down just to keep kind of our work organized and why we're doing what we're doing. Okay, so for each side, the height of the prism, so if we set that triangular prism on its base, the height of the prism would be 6. So the height of each of these is 6. And let's look at the triangle. Is the triangle an equilateral? Is the triangle isosceles? So we know this bottom part of the triangle is 7. So there's going to be one that's a 7. This is 6.1. 6.1. And because they didn't give us the length of this side, it's likely the exact same as it is the exact same as that side. So it's 6.1 as well. Alrighty, so let's finish out our formula by plugging in. So we've got, plus 6 by 7 plus 6 by 6.1 plus 6 by 6.1. Okay, minus 2 times 6 times 7. Alright, let's plug in our rectangular prism. We've got 7, 6, and 5. So 2 times 7 times 6. It's 2 times 7 times 5 plus 2 times 6 times 5. And again, in order is totally fine. Alrighty, so now let's just do a lot of calculations. 84. 70. Alrighty, 84 plus 70 plus 60. Oh, I just did times. 84 plus 70 plus 60. 214 plus 35 plus 42 plus 36.6 149.2 minus the area of overlap, we get 84. Okay, so 149.2 plus 214 gives us 363.2 minus 84. Let's see. We get 279.2. And let's see. Because we have surface area, it is centimeters squared. Alrighty, so again, there are no Goddets because I wasn't a fan of how they were written, but use your notes to help guide you through the homework. You've got 1 through 4 on both pages. All work needs to be shown in your notebook. So my expectation is that you will upload a picture of or a scan of your notebook.